Hello students, welcome to the amazing platform of Physics Wallah. Welcome to the PW English channel, my dear students. So today we have reached on the lecture 5 of electrochemistry, my dear students. What are we going to discuss? We have discussed everything about galvanic cell. What is a galvanic cell? How spontaneous reactions takes place in it, and everything. How do we calculate the EMF of these cells and all. Now, my dear students, we will be discussing about electrolysis. That is a process that takes place in the electrolytic cell. And I hope all of you remember that electrolytic cell is a cell where non-spontaneous reactions takes place, right? Yes. So let's start the amazing session, my dear students. What are we going to discuss today? We are going to discuss about electrolysis, and then we'll be solving a lot of practice questions. So let's start. Now, first, let's talk about electrolysis. Whatever we studied in the first class, we'll be revising that, and then we'll be deducing some information from that. Okay, so now, my dear students, when I talk about electrolysis, you should understand that this is a process that takes place in a electrolytic cell. Okay, now let's discuss what were the things that we had discussed about electrolytic cell. You told that, ma'am, electrolytic cell is a cell where non-spontaneous reactions takes place. This means that non-spontaneous reactions takes place. Okay, the second thing which we can remember is that if non-spontaneous reactions are taking place, this means that Gibbs free energy should be positive, right? So, ma'am, delta G should be equal to a positive value. Next, my dear students, we talked about the conversion of energies. When we talked about electrolytic cell, what were the discussion, ma'am? Electrolytic cell means that where non-spontaneous reaction means you need an external force. So, the charging of the phone was actually an example of electrolytic cell, and in charging we say that electrical energy is converted into chemical energy. Right? Yes, perfect. So, ma'am, electrical energy is converted into chemical energy in an electrolytic cell. Okay, I hope everything is clear till now. This is something which we are only revising. Now, if we talk about electrolytic cell, we need to find out which is cathode and which is anode. How are we going to do that? We have to consider a cell first. So, let's consider a cell. You have a cell something like this. Okay, then, my dear students, you had electrodes here. Then you had electrodes here. Now let us consider that it is an molten NaCl solution. So you have Na plus and Cl minus ions in the solution. Okay. Now you also know that since it is a non-spontaneous cell, so it needs some external force. So external force would be something like this. Right? Yes. And ma'am, we would say that this is positively charged and this is negatively charged. Yes. So from here, we can say that this particular electrode is negatively charged and this particular electrode is positively charged. Right? Yes. I hope everything is clear till now. Now, my dear students, what are we going to do? We will be understanding every concept in detail. Now, if you talk about a positively charged ion, what will it do? Positive in the charges, opposites attract. So if we are talking about a positive charge, it will tend to go to the negatively charged electrode, right? Yes. So I can say that this will go towards the negatively charged electrode. Right? Yes. And if you talk about Cl minus, my dear students, it is a negatively charged electrode. So it tends to go to the positively charged electrode. I don't know which is cathode, which is anode, but I know this thing. This is so normal, which we have been studying since I think 2 to 3 years, that opposite charges attract. So I just used that concept. Now let's write the reactions and find out which is the electrode and which is the which is the anode and which is the cathode. So if I talk about Na plus, then my dear students, Na plus aqueous will gain an electron and it will give you Na solid. I hope everything is clear till now. Yes, ma'am, this is the reaction that will take place. If I talk about Cl minus, then my dear students, Cl minus will go to a positively charged electrode and it will give you Cl2 plus electron, half Cl2 plus electron. These are the reactions that will actually take place. Let me write it. of Cl2 plus electron. Okay. Yes, I hope you're clear till now. Now let's see which of the following is a cathode and which of the following is a anode. I know that loss of electron is oxidation and gain of electron is reduction. I also know that oxidation always takes place on anode and reduction always takes place at cathode. Okay, so now if I see here, my dear students, what is happening? Gain of electron. So can I say reduction? If reduction is taking place, this means that this is your cathode. This means that this is your cathode, right? Yes. And if I talk about the Cl minus, my dear students, Cl negative is losing one electron. This means that this is oxidation. Loss of electron is oxidation, and oxidation always and always takes place at anode. So this is my anode. So from here I can say that this is my anode and this is my cathode. See, you need not memorize things, you just need to interpret things. Okay, yes, I hope it is clear till now. How we found out cathode and anode, we have already discussed this, so I'm not making you revise everything all over again. We are actually revising this only. Okay, now if we are thorough with this concept, can I say that in an electrolytic cell your cathode is always negatively charged and your anode is always positively charged? So let's write this. Notes. Let's talk about electrolysis. See, my dear students, electrolysis is a process that takes place in an electrolytic cell. So can I say that the process takes place in electrolytic cell? This is a process that takes place in an electrolytic cell. Second thing is that non-spontaneous reactions take place. I hope we are clear with this concept. It is very clear with us. Now let's talk about the other thing. If I talk about the electrodes, my dear students, I will say that in an electrolytic cell, a cathode is always negatively charged. So in electrolytic cell, cathode is negatively charged. These are the questions which are generally asked, so we need to make them as points. Anode is always positively charged, and we know that on anode oxidation will take place and on cathode reduction will take place. I hope I need not write it all over again. Yes, now till now we are clear with the concept. Now the next thing which we need to understand is, my dear students, that if you see you have Na plus. Na plus is a cation, right? Yes, a positively charged ion is known as your cation, and cation will always get reduced on the cathode. This is something which you need to understand, that the positively charged ion in an electrolytic cell will always get reduced on the cathode, right? Yes, so you will write that positively charged ion always gets reduced on cathode. And if you see here, my dear students, your negatively charged ion, which is Cl minus, or be it any negatively charged ion, which is also known as your anion, will always get oxidized on the anode. Here, my dear students, oxidation will take place. So we can say that negatively charged ions always get oxidized at anode. This is something to memorize, my dear students. If you need to understand it, you can understand, right? You need not memorize that positively charged ion will always get reduced on cathode and your negatively charged ion will always get oxidized on anode. These are the few things which you need to understand. You need to have clear in your mind, because only then you will be able to solve your questions, right? Yes, you need to go through these all points. Most of the questions are asked from this particular slide, so write these, understand this, and then we'll move forward. Okay, I hope we are clear with this. Now can we move forward? Yes, we can move forward now, my dear students. Now after this we will be understanding a few things. Let me tell you, if I talk about my dear students, let's say I gave you a reaction Na plus, okay, I'm sorry, Na plus electron gives you Na solid. Okay, so this is the particular reaction. So if I have one ion, only one ion of Na plus, I can say one electron reduces it. Yes, if I take two anions, Na plus ions, then I will say that I need two electrons. Can I say that if I have 1 mole of Na plus, then I need 1 mole of electron? So this is how you read a particular reaction. In a particular reaction, you need to understand that how you read the stoichiometry. For using, if you use 1 mole of Na plus ions, you require 1 mole of electron to reduce 1 mole of Na plus ion to 1 mole of Na solid. So this is how we read these. Okay, yes. Now let me give you a very easy question. 6 moles of electron are used for reduction of Na plus to Na solid. Give the moles of Na solid deposited. See, how are we going to solve this question? See, it is very clear. That since we are talking for an electrolysis process, this means that Na plus is a positively charged ion, and in an electrolysis process, your positively charged ions are always reduced at cathode. So your reaction would be Na plus electron should give you Na solid. Reduction at cathode. This is the first thing which you need to take out of this particular question. After that, my dear students, Na plus has gained an electron and gave you Na solid. Now you know that you can say that 1 mole of Na plus uses 1 mole of electron and 1 mole of sodium is deposited. How many moles of electron are used? 6 moles of electron are used. You have to tell how many moles of sodium are deposited. So when 1 mole of electron is used, 1 mole of sodium is deposited. If 6 moles of electron are used, then 6 moles of sodium will be deposited. So this is how you solve the question. You need to use the unitary method to find out that how many moles of a particular moles of electron are being used to produce a particular amount of solid. Okay, yes, I hope you're clear with this. This is how we will be solving questions. So if you want, you can write it and then we'll move forward. Okay, now let's move forward. Now we have written this. Now, my dear students, we'll be starting a very easy topic again. See, if I tell you that charge on 1 electron is minus 1.6 into 10 raised to the power minus 19 coulombs. You will be very clear with this. Yes. So we will be using, my dear students, the mod of this value, only the numerical value of this value. So I'll write mod here. I hope you're clear with this. If I talk about, give me the charge on 2 electrons. What will you say? You will say, ma'am, it will be 2 into 1.6 into 10 raised to the power minus 19, right? If you want to write mod, then here is mod, right? Yes. This is the charge for 2 electrons. Similarly, for 3, we'll multiply by 3 and so on. So if I ask you just the way charge on Na moles of electron, sorry, Na electrons, what will you say? Okay, let's write it like this. Charge on 1 mole of electron. 1 mole of electron. Right? Yes. So if I have 1 electron, charges 1 into 1.6 into 10 raised to the power minus 19 coulomb. If I have 2 electrons, then 2 into the charge. 3, then 3. If I have 1 mole of electrons, this means that Avogadro number into minus 1.6 into 10 raised to the power minus 19 coulombs. Right? Yes. And this is 6.022 into 10 raised to the power 23 into minus 1.6 into 10 raised to the power minus 19 coulombs. When you multiply this complete value, my dear students, you get total value near close to 96500 coulomb. You get the value as 96500 coulomb. And this value is very important. Why this is important? Because this is the charge on 1 mole of electron, and you will be using it all over again and again and again. So you need to know this, right? And the scientist, just to simplify it, gave it a value equal to 1 Faraday. They said, let's call it 1 Faraday. So the value of 1 Faraday is 96500 coulomb. Okay. So can I say that what is 1 Faraday? 1 Faraday is the charge on 1 mole of electron. Charge on 1 mole of electron is known as 1 Faraday, and the value of 1 Faraday is 96500 coulomb. Right? Yes. Okay. Till now everything is clear. If you want to write it, just write it and then we'll move forward. Okay. I hope you've written this. I hope you've paused the video and written this. Now what I want to tell you, now give me the charge on 1 mole of electron. You will say, ma'am, it will be 1 into 96500. If I ask you charge on 2 moles of electron, what will you say, ma'am? It is 2 into 96500 coulomb. Right? Similarly, 3, 4, 5, 6, I hope you will keep moving like this. If I ask, so my dear students, can I say that you have 1 mole of electron? I can say this is equal to 1 Faraday because 1 Faraday is this. I can say this is equal to 2 Faraday. Can I say charge on 3 mole electron? That would be 3 into 96500, which is equal to 3 Faraday. This means that the number of moles of electron you're taking, the number of Faraday is also same. If you have 1 mole of electron, 1 Faraday charge. If you have 2 moles of electron, 2 Faraday charge. 3 moles of electron, 3 Faraday charge. So I can say that number of Faraday used is equal to the moles of electron. I hope we can make this deduction, that the number of Faradays is actually equal to the moles of electron that you have been using in your reaction. Right? Yes, I hope till now everything is clear. You don't have any issue till now. Perfect. Now, my dear students, we know that whatever the moles of electron is, the number of Faradays are same. Okay, so can we give a formula, my dear students? Can we give a formula from here? If you have to calculate, if you are given some charge, can you calculate the Faraday? How can you calculate the Faraday? See, let me give you a question. Give number of Faradays in 9650 coulomb charge. You have a charge of 9650 coulomb, and you have to give me the number of Faradays. Okay. Perfect. Now let's start. How will you do this? See, my dear students, you know that 1 Faraday charges 96500 coulomb. So let's use the unitary method. Ma'am, in unitary method, I know that 96500 coulomb charge is present in 1 Faraday. Then 1 coulomb charge will be present in 1 upon 96500 Faradays. and you have to calculate this much charge. So this means that 9650 coulomb charge will be present in 1 upon 96500 into 9650, which is equal to 0.1 Faraday. Right? Yes. So if you are given charge, you can use the unitary method and calculate the number of Faradays. Right? Yes, you can do that. You don't have that problem. We have been using unitary method since our, I guess, second or third class. Yes. Okay. So, but every time using this unitary method will be a very hectic task for us. So now let's find a formula to calculate the Faradays if we are given the charge. Right? Yes. So now we'll be calculating of writing a formula. Number of Faradays will be equal to given charge, whatever the given charge is in coulombs, divided by 1 Faraday. Right? Yes, or we can say number of Faradays is equal to given charge in coulombs divided by 96500, because 1 Faraday's value is equal to 96500 coulombs. So this is the formula that we came out with. Right? Yes, this is the number of Faradays you can calculate if you are given the charge. Okay, now if I tell you any charge, let me say give me the amount of Faradays or the number of Faradays in 96500000000 coulomb. What will you do? You'll just write the given value divided by this and you'll find out the number of Faradays. If you know the number of Faradays, you can tell me how many moles of electrons are being used. Right? It is a beautiful concept. Now we are thorough with this. Okay, yes, perfect. I hope till now everything is clear. We have understood what is 1 Faraday. We understood that the number of Faradays is equal to the moles of electron used. How can we calculate the number of Faradays? We have discussed that as well. Okay, now my dear students, what if you're not given the charge in coulombs? You have to calculate the charge as well. So the next topic is this, you might have studied in physics also, calculation of charge. Calculation of charge, and charge symbol is Q. Okay, so now my dear students, you might know that Q is equal to I into T. Now let's understand what each term denotes here. Here Q denotes your charge in coulombs. If you talk about I is your current in ampere, and T is your time in seconds. Now, a lot of times you're not given the charge, but you are given the current and the time. So if you are given current and time, you can calculate the charge as Q is equal to I into T. Okay, so if we incorporate this particular formula into the number of Faraday's formula, what the expression would become? Number of Faradays will be equal to charge Q upon 96500, which is equal to I into T upon 96500. So this will be your formula. This will be your formula for calculating the number of Faradays if you are given the current and the time. Right? Yes, I hope you don't have any issue. This is a very easy formula which you have been using in your physics. Right? Yes. So you can note it down and then we'll move forward. From where you need to write, we have written this part, write this, then let's move forward. You can write this, then you can write this, and then you can write this. Okay, yes. Okay, my dear students, till now everything is clear. Now we will be using all the concepts which we have discussed till now in a one particular question. I'll make you understand how you will be solving the questions, and every time you'll follow those steps and you will definitely come out with the absolutely correct answer. Okay, so let's start, my dear students. You have a question, just read the question. Question says that 96.5 ampere of current was passed through molten NaCl for 1 minute and 40 seconds. Find out the amount of sodium deposited at the cathode and the volume of Cl2 evolved at the anode. Okay, so now how are we going to tackle such type of questions? This question is too complicated. I hope you are feeling I feel like you're feeling this, but after just seeing the expressions, how are we going to solve? You will be like, such an easy question, ma'am. Right? Yes. So let's start. You have NaCl. Can you tell me that if you have NaCl, my dear students, and electrolysis process is taking place, then what will happen? The first and the most important thing which I can deduce is that the positively charged ion will get reduced on cathode, so the reaction would be Na plus electron will give me Na solid. This is the first reaction that will take place, and this is something I can deduce. Okay. The second thing is that what will happen on anode? Oxidation will take place. So you will have Cl minus, this will give you half Cl2, plus you will get electron. This is the reaction that will take place on anode. Okay, these are the two reactions on electrolysis process that will take place, which we have understood. The positively charged ion is always reduced on cathode, and the negatively charged ion is always oxidized on the anode. Okay, yes. Now read the question. Current is given to be how much? 96.5 ampere of current was passed through molten NaCl for time is given 1 minute 40 seconds. So let's convert it into seconds. So 60 plus 40, which is equal to 100 seconds. So this is the time that you have been given. Okay. Find out the amount of sodium deposited. So my dear students, you have to find out the amount of sodium. This means that you have to calculate its mass, that how much sodium is deposited. This is the first part. And you have to calculate the volume of Cl2 evolved at the anode. This means that you have to give me the volume of this particular Cl2 as well. So you have two parts in this question. Okay. Now, you are given current and time, and you are calculating these two things. How will you do this? Okay, see my dear students, if somehow I come to know that how many moles of electron I have used, how many moles of electron are being used, if somehow I calculate this, I can use the stoichiometry and calculate the amount of sodium deposited and the volume of Cl2 evolved, right? Yes, we can find this out. So our target is to calculate the moles of electron. And how can we calculate the moles of electron? I remember that the number of Faradays are always equal to the moles of electron. So for that, I need to calculate the number of Faradays. And for calculating number of Faradays, what do I want? I just want to use a formula which I know. So now I'll make you write the steps as well. Just follow me. The first and the most important thing I'll calculate is charge. Charge is equal to I into T. This means that 96.5 into time 100. This is 9650 coulomb. So this is the charge that has came out. Now I want to calculate the number of Faradays. So for calculating the number of Faradays, I know that given charge upon 96500 will give me the amount of number of Faradays. So what is the charge? 9650 divided by 96500, which is equal to 0.1 Faraday. So your number of Faradays that you have calculated are 0.1. Now imagine your number of Faradays are 0.1, and you know you have deduced this thing that moles of electron are actually equal to the number of Faraday. So moles of electron will be equal to 0.1. Clear? So this is how you have calculated that how many moles of electron are being used. Okay, so now we can do both the parts. Now let's calculate sodium deposited. Amount of sodium deposited. For that I need the reaction of cathode. Na plus electron gives me Na solid. Now see, when you have 1 mole of electron, 1 mole of sodium solid is deposited. So 1 mole electron gives me 1 mole of sodium solid. So if I have 0.1 mole electron, then I'll have 0.1 mole sodium deposited. Simple unitary method, right? So your moles of sodium solid has came out to be 0.1. Can you calculate the mass of sodium? This will be number of moles into molar mass. Number of moles are 0.1, molar mass is Molar mass is how much? How much? You have sodium, it is 23. So this will be 2.3 grams. So 2.3 grams of sodium is deposited on the cathode. So you can write 2.3 gram of sodium deposited on cathode. So this is the first part that we have done. Just go through it, my dear students. Just go through it. You need to understand this because the second part you are supposed to do yourself. Okay, so try this. Try to understand this. Okay, I hope you have understood how you have done this particular part. Okay, now let's do the second part and understand it a little bit more. Second part was volume of Cl2. So for calculating the volume of Cl2, I need the anode reaction. So I'll write the anode reaction. It will be Cl minus gives me half Cl2 plus electron. See, now you know that this Cl2 is a gas. You know that this Cl2 is a gas. Okay, so now you are going, how you're going to solve this question? Just see. When you use 1 mole of electron, you get, when Cl negative is oxidized, then 1 mole of electron are lost and half moles of Cl2 is formed or evolved. So can I say that moles, when I have 1 mole of electron, I have half moles of Cl2. Okay, how many moles of electron do I have? 0.1. So if I have 0.1 mole electron, then 1 by 2 into 0.1 mole of Cl2. So the moles of Cl2 that came out to be are 1 upon 2 into 0.1, which is equal to 0.1 upon 2. You need to calculate the volume of Cl2. You have to use the STP conditions. I know that 1 mole of any gas will occupy 22.4 liters of volume, right? Yes. So ma'am, volume of Cl2 will be equal to moles into 22.4 liters. This will be 0.1 upon 2 into 22.4. This will be 11.2. So this will be 1.12 liters. So we can say that 1.12 liters of Cl2 is evolved at anode. So this much volume of Cl2 has been evolved at anode. So I hope you're clear with this, my dear students, that just to calculate the amounts of products formed, you need moles of electron. And for calculating moles of electron, you need number of Faradays. And for calculating number of Faradays, you need charge. And charge is equal to current into time. Okay, yes. Just go through it. I'll make you write all these steps. Just write it and then we'll move forward. Pause the video and write it. Pause the video and write it. So now let's generalize what we have studied till now. How are we going to solve the electrolysis questions? So the rules, there are a few steps to be followed. So I'll write steps to be followed. So the first step to be followed is, my dear students, calculate charge. And how are you going to calculate the charge? Q is equal to current into time. The first and the most important thing is you will calculate the charge. Second, calculate number of Faradays. Number of Faradays. And how are you going to calculate the number of Faradays? Number of Faraday will be equal to given charge upon 96500 coulomb, which is charge on 1 mole of electron. Okay, so this is how you will calculate the number of Faradays. What will be your third step? Number of Faradays will be equal to, calculate moles of electron. And how can you calculate the moles of electron? You can calculate by number of Faradays is actually equal to moles of electron. Once you have calculated the number of the moles of electron, what can you do? Use moles of electron in the cathodic and anodic reactions and calculate using stoichiometry. Right? Yes. These are the steps to be followed every time. Whenever you are given current and time, calculate the charge. Once the charge is calculated, calculate the number of Faradays. Once the number of Faradays are calculated, number of Faraday will be equal to the moles of electron. Moles of electron will be used in the required reaction through stoichiometry. You can find whatever you are asked. This is a very important trick. You will be able to do every question asked by the Faraday's law. You need not memorize the Faraday law. This is the most easy trick to solve the electrolysis questions, my dear students. I hope you're clear with this. You can pause the video and write it, and then we'll move forward. Let's move forward. Now you have a question on your screens. Try to do this question yourself. Okay, I'll give you all the hints for this question, but you'll have to do this question yourself. So for this question, you need to understand hydrolysis of water. Hydrolysis of water. So now, what happens in hydrolysis of water, my dear students? Again, you have H2O, you will have two ions, you will have H plus and you will have OH minus. So whenever you do hydrolysis of water, you will have a cathodic reaction and an anodic reaction. So you need to understand which reaction will take place where. Now, you know that this is a positively charged ion. So positively charged ions are reduced on the cathode, right? Yes. So here we can say that the reaction will take place at cathode. Reduction will take place. So H plus will gain electron and it will give you H2 gas, and that too half, just to satisfy the stoichiometry, balanced chemical reaction. This is the cathodic reaction. It was very easy. Now let's talk about the anodic reaction. What will happen on the anode is, my dear students, oxidation, and oxidation will take place for negatively charged ion, and your negatively charged ion is 4OH minus. No, so now you need to memorize this reaction. I am sorry, but you have to memorize this reaction. 4OH minus gives you 4 electrons plus O2 plus 2H2O. This is the oxidation of OH minus that takes place. Okay, so you need to memorize these two reactions, my dear students. Okay, so the reduction reaction will be this. H plus plus electron gives you half H2, and the oxidation reaction would be anode. 4OH minus gives you 4 electron plus O2 plus 2H2O. Okay, now if I ask you, because generally in questions it is asked that calculate the total volume of gas evolved. So my dear students, total volume of gas evolved is C. You know that this is gas, you know that O2 is also gas. So on cathode, H2 gas is evolved. At anode, my dear students, O2 gas is evolved. So the total volume that is evolved is volume of H2 plus volume of O2. So whenever it is asked that you have to give the total volume, then you have to sum both of the volumes. And if you are asked only one particular volume, either at cathode or anode, then you can give your answer yourself. But make it a point that if you are asked total volume, then you have to solve it like this. Okay, you calculate using the stoichiometry here, then calculate using the stoichiometry here, add both of them, and then you will get your answer. Okay, perfect. So this is the hydrolysis of H2O that you need to understand. I'll have some water and then we'll move forward. If you want to write it, just write it. Okay. now you can solve this question. See, I'll give you all the hints. You'll only have to solve it. You are given current 4.25 ampere. You are given time 1 minute, which is equal to 60 seconds. From here, you will calculate the Q charge, which is equal to I into T. Then you will calculate Faraday, which will be equal to Q upon 96500. And you know that this will be equal to moles of electron. These are the few things that you needed to understand, and you applying all the steps you have calculated till now. It is asking you that this much current is passed through water, that is your H2O. Find out the total volume of all the gases. Now you know that electrolysis of water is taking place, so you need to write the anode reaction. 4OH minus gives you 4 electrons plus 2H2O plus O2. And at cathode, you have H plus electron gives you half H2. So now you ask the total volume. So use these moles of electrons, which you will calculate here. Once in the anodic reaction, calculate the volume of O2, and once in the cathodic reaction, calculate the volume of H2. And my dear students, total volume will be equal to volume of H2 plus volume of O2. So I have done everything for you. You just need to calculate. You just need to put the values and solve the question. Okay? Yes. So this is how you will be solving this question. If you have got this particular part, my dear students, congratulations. You have excelled electrolysis as well. Such an easy part. And now you can solve any question, be it anything. Okay? Yes. So you can pause this and then we'll move forward. I hope you've written this. Now let's move forward, my dear students. What are we going to discuss next? Next now, my dear students, we are going to discuss a very important thing. Till now, I gave you an electrolytic solution. Let us say NaCl. We had only one Na plus ion and we had only one Cl minus ion. One of them got reduced and one of them got oxidized on the anode. Now, what happens if you have two different ions from which you have to choose? One of them will be going into oxidation or reduction. So now we are going to understand this particular part, right? Yes. So it is the preferential discharge of cations and anions, and the electrode which you are using are inert electrodes. That is the most important thing, that these are the inert electrodes. Now let's move forward, my dear students, and understand this. Okay. Now, imagine I gave you a solution, or let's say aqueous NaCl solution. Now, if I talk about aqueous NaCl solution, this means that I have Na plus ion and I have Cl minus ion. But my dear students, you know that aqueous means your solvent is water. And what if your water is also getting electrolyzed? And if water is getting electrolyzed, then I have H plus ion and OH minus ion here as well. Now the problem arises. You have cathode here, because you know the positively charged ions will get reduced, and you have anode here. Your negatively charged ions will get oxidized. Okay. Now, imagine, my dear students, you have these and these ions. Now, my question to you is, out of Na plus and H plus, which of them will get reduced on the cathode? This is the question. This is the problem now, because you have two positively charged ions and both of them will not get oxidized. Sorry, both of them will not get reduced. One of them will get reduced and the other will stay in the solution. So, out of Na plus and H plus, I need one ion which will get reduced. Okay. So, ma'am, we know that at cathode always reduction takes place. This means that out of these two ions, the one which will have more reduction potential will get reduced first, so it will go to the cathode and the other will stay in the solution. Okay, this is the trick that you follow. So for positively charged ions, you use the electrochemical series, and electrochemical series, you know that as you move from top to bottom, your reduction potential decreases. Your reduction potential decreases, right? Yes. I am sorry, your reduction potential actually increases. right? Yes. So the ion which is below, the more the below in the electrochemical series, the more it will have its reduction potential, and the more it will have the tendency to go towards the cathode. Okay, so this is how I can say that if I have zinc and hydrogen, which of them will get reduced? I will say hydrogen will get reduced because hydrogen has a higher reduction potential. So the ion which is below in the electrochemical series will get reduced. Okay. Yes, perfect. So now we can say that here is a cathode, here is a anode, right? Yes. So now let's talk about cathode. I have Na plus and I have H plus. So we need to see that which of the following will have the higher reduction potential. Okay. So see here, you have Na here and you have hydrogen here. So this is the hydrogen, this is the sodium. So which of the following has the higher reduction potential? You will say, ma'am, hydrogen has a higher reduction potential, so it will tend to move towards the cathode and get reduced, and your Na will remain in the solution now. So this as a higher reduction potential, so you can say that this reaction will take place because your H plus will get reduced. So we can say that since H plus has higher reduction potential, so it gets reduced at cathode. So every time whenever you have more than two ions, you just need to see which of the following has a high reduction potential, that will go towards the cathode and will get reduced. Now let's talk about the anode. You have Cl minus and you have OH minus. Okay, now ma'am, in this case what will we do? My dear students, you have to see the oxidation potential, and generally a very generalized form is given here. Generally these ions are asked, and this is the preferential discharge. Whenever you will talk about Cl minus and OH minus, always Cl minus will get oxidized first. Okay, so this is the trend. You just need to memorize this trend and nothing else. Perfect. I hope you're clear with this. So now we can say that out of Cl minus and OH minus, Cl minus will get oxidized on anode. So ma'am, here I can say that Cl minus will get oxidized, and the reaction would be Cl minus will go into half Cl2 plus electron. Okay, so this is how you will do the preferential discharge. So what will be left in your solution? If you see, you will say, ma'am, Na plus and OH minus will stay in my solution. So what is your solution? Your solution is NaOH. Your solution is NaOH. So can I say that the solution is basic in nature? Because NaOH is alkaline in nature. So this is how you deduce information. Three different things you've understood: which of the following is getting oxidized, which is getting reduced, and the last is what nature will be your solution. Will it be acidic, basic, or neutral, right? Yes. So this is how we use the preferential discharge of cations and anions. If you want to write it, and then we'll move forward. Let's talk about the other part. Now this is your now this you have to do on your own. Aqueous CuSO4 solution. Pause the video, try the question yourself, and then you will see my approach. Okay, so now you have copper sulfate solution. So this means that you have copper 2 plus and you have SO4 2 minus, and you have aqueous. So this is H plus and this is OH minus. Okay, so ma'am, if I see here, I have to check whether copper 2 plus or H plus has a higher reduction potential. So let's move to the electrochemical series. Copper and hydrogen, my dear students, here is your copper, hydrogen, and here is your copper. So copper has a higher reduction potential, so copper will get reduced. So can I say that copper will go towards the cathode, and the reaction that will take place is copper 2 plus 2 electrons will give me copper solid. And if I talk about SO4 2 minus and OH minus, my dear students, just check. You will see that OH minus is here, SO4 2 minus here is here. So OH minus will get oxidized on the anode, and the reaction would be 4 OH minus gives you 4 electrons plus O2 plus 2 H2O. Right? Yes. So what will be your solution? What will be in your solution? You will say in my solution I'll have H plus and SO4 minus. So you will have H2SO4 solution, and you will say the solution is, or we would say it is acidic medium, right? Because H2SO4 is a acid, right? Yes. So this is how you deduce informations from the given part. Perfect. I hope you're clear with this. You can write it and then we'll move forward. Okay, let's move forward. Now you have, my dear students, aqueous AgNO3 solution. Now you have to tell me about aqueous AgNO3 solution. Okay, so if you have aqueous AgNO3 solution, pause the video, try the question yourself. You will have Ag plus, you will have NO3 minus, you will have H plus, and you will have OH minus. At cathode, my dear students, if you see the electrochemical series, I'll just show you the electrochemical series. You have H plus here and you have Ag here. So Ag has a higher reduction potential. So Ag will get reduced. So ma'am, Ag will get reduced. So you will have Ag plus electron giving you Ag solid at the cathode. If you talk about anode, again, my dear students, electrochemical series, OH minus will move. If you want to see, then just go through it. See, here is OH minus, here is NO3 minus. So OH minus will get oxidized. So at anode, your reaction would be 4 OH minus giving you 4 electrons plus O2 plus 2H2O, right? And what will be the medium? H plus and OH, H plus and NO3, so HNO3, so again acidic. So this is how you solve the questions. This is how you solve the question. Please go through it and then we'll move forward. Let's move forward now, my dear students. Till now, we were discussing about the electrodes that were your platinum, palladium, which were inert electrodes which do not react with any of the electrolytes in your solution, right? Yes. Now, what if you use some reactive electrodes? Then, my dear students, the components which are going to be reduced or oxidized changes. Now let's discuss about that. The first is your aqueous copper sulfate solution with copper electrode. This is an example. Now you'll understand this. See, you have an aqueous copper sulfate solution. You have the solution of that ion and you have the electrode of the same metal. The same metal electrode and its aqueous solution. Then, my dear students, always and always that particular ion will get reduced. You have copper sulfate solution and you have copper electrode. Then always and always at your electrode, the reduction, at your cathode, the reduction will take place for copper. Okay, I hope you're clear with this. Imagine if you have aqueous AgNO3 solution and you have Ag electrode. Then you know that Ag plus is an ion, my dear students. It will only get reduced to get converted into Ag solid. So whichever metal electrode you are given, and if you have the same electrode same metal's aqueous solution, then only that metal will get reduced. Okay, yes. So this is the first part. The second part is aqueous NaCl solution with Hg electrode. Now imagine if I talk about aqueous NaCl solution. See, till now what we have discussed, we say that we have Na plus ion and we have H plus ion. Since H plus ion has a higher reduction potential, so this will get reduced, right? Yes. This was when you had inert electrodes. But what if you don't have inert electrodes? If you have a Hg electrode, my dear students, then a change comes. Then what happens? Your hydrogen will not get reduced. Your sodium will get reduced on the Hg electrode, and your reaction would be Na plus electron, which will give you Na solid, and this solid will then go and form an amalgam with your mercury, and this is highly stable, and that is the reason whenever your electrode will be mercury and you have an aqueous solution of Na plus ion present, definitely that will get reduced. Why? Because it will form amalgam and that is very stable. Okay, so this is the another important thing which you need to understand. You need to see which electrode is being used. Let's talk about the other, which is your concentrated H2SO4 solution with platinum electrode. So my dear students, if you are given concentrated H2SO4, then at anode your reaction, at cathode your reaction will be always and always H plus electron will give you half H2. And if you talk about anode, my dear students, then your SO4 2 minus will get converted into S2O4 2 negative. Here it will be 2 plus 2 electrons. These are the reactions which will take place when you have concentrated sulfuric, concentrated H2SO4 solution. Okay, at anode and at cathode, the reactions are fixed. If you have concentrated H2SO4 solution present. I hope you're clear with this. If you want to write it, because these are the few things which you need to keep in your mind. Write it and then we'll move forward. You can write this. Okay, now let's discuss whatever we have discussed till now. Let's revise everything and be thorough with our concepts. Okay, so the first part says you are given the electrolytes, you will have to give me the reactions. Let's not write product. Let's say you will have to give me the reaction on anode, on cathode, and then you will have to give me the medium of your solution. Okay, so now let's move forward. You have, my dear students, AgNO3 solution, you have AgNO3 solution, and you have Ag electrode. When you have the same metals electrode and the same metals aqueous solution, then what happens? Only that particular ion gets reduced, right? Yes. So we can say that here, my dear students, we can say that your Ag plus will gain electron and get converted into Ag solid. It will get converted into Ag solid. Okay, yes, I hope you're clear with this. Now let's move forward to the next part, which is your second part. This is your aqueous AgNO3 solution, and now you have a platinum electrode, my dear students. Now one more thing, again we have to see the preferential discharges, right? You have Ag plus, you had H plus, you have NO3 negative, and you have OH minus negative, right? Yes. So here, since the Ag electrode was used, this got reduced. Now you need to see the oxidized part. You will say, ma'am, OH minus will get oxidized, so the reaction at anode would be 4 OH minus gives you 4 electron plus O2 plus 2 H2O. So this is the reaction that will take place on anode. And if we see the medium, we can say HNO3, so the medium would be acidic. So the medium would be acidic in nature. This is how you will be solving the questions. Now let's move forward to the next part. Next is your aqueous AgNO3 platinum electrode. Now you have platinum electrode. Now, my dear students, you have Ag plus, you have H plus, you have NO3 negative, and you have OH minus. Since it is inert electrode, so you need not see anything. You just need to see the electrolysis, your electrochemical series, and according to the electrochemical series, this will get reduced. So the reaction again would be Ag plus will gain electron and give you Ag solid. And there, my dear students, again OH minus. So 4 OH minus will give you 4 electrons plus O2 plus 2H2O. Right? Yes. And this would be acidic in nature. Why? Because again you will have HNO3 present. Let's talk about the aqueous PbCl2 solution. Can I give you this as your homework? Will you do this question? Of course you will do this question. So this is your homework question. Just see the electrochemical series, my dear students. It is a platinum electrode, so it is an inert electrode. So you just need to see the electrochemical series, see which of the following will get reduced. See the for the anionic part, see that chart I have given you, see which of the following will get oxidized, and then you will give me the solution, a medium also. So this is your homework. Okay, yes, I hope you're clear with this. You can pause the video, write it, and then we'll move forward. Okay. Now, my dear students, what happens is sometimes the questions would be remaining same, but sometimes you are given some current efficiency. What does current efficiency mean? Current efficiency means that, let us say I gave you 20 ampere of current. We used 20 ampere of current, but sometimes that 20 ampere of current is not completely used. Okay, its efficiency is only 50%. So what efficiency means, that if you had 20 ampere of current but only 10 ampere of current was useful, the rest 10 ampere of current was not useful, so we give the current efficiency. Okay, so what is the current efficiency? Current efficiency is the current used upon total current into 100. This is the formula for current efficiency. Let me give you an example and then you will be clear with the concept. Question is, you have 20 ampere of current passed. Okay, and current efficiency is, let us say, 80%. Calculate moles of electron used. How are we going to do this question? See, very easy question, very easy question. First, my dear students, you are given the current as 20 ampere. So your current is 20 ampere. Okay, I haven't given you the time. Let me give you time. Time is 100 seconds. Okay, I hope you're clear with this now. Your current is 20 ampere, but this current is not efficient. This total current cannot be used. The efficient current is only 80%. So your I dash would be equal to, your I dash will be equal to 80 upon 100 of I. 80 upon 100 of I is 20. So 80 upon 100 of 20. 8 into 2 is 16 ampere. So 16 ampere of current is useful. The rest is not useful. So if you will calculate the charge, you will say this will be equal to I dash into T and not the I. So when you are given current efficiency, you find the efficient current and then you calculate the charge according to that efficient current. So your efficient current is 16 into time is 100. So this would be 1600 coulombs of charge. Now you have to calculate the number of Faradays. So number of Faradays will be equal to charge 1600 upon 96500, and then you will calculate this will be equal to your moles of electron. So this is how you will calculate the moles of electron. Just the thing that you need to understand when you are given current efficiency is that the current which is used is your efficient current, and then you will have to calculate it this process, and then you will have to calculate the moles of electron. Rest everything remains same, nothing is changed. Okay, I hope you're clear with this. Now we can move forward. Let's move forward, my dear students. If you want to write it, and then we'll move forward. Okay. Here is a question. You have 96.5 ampere of current passed for 200 seconds through a solution of molten NaCl. Find the mass of Cl2 liberated. Try this question. Pause the video. Try this question. We have done a lot of practice now. Okay. So now, my dear students, see. Your current is given to be 96.5. Is the current efficiency given? No. So no problem. Your time is given to be 200 seconds. So this is 200 seconds. Okay. So can I calculate Q? Yes, ma'am. I into T, which is equal to 96.5 into 200. Okay. Let's keep it like this. Let's keep it as 9650 into 2. So this is your charge. So can you calculate the number of Faradays? Yes, ma'am. Charge upon 96500. This would be 96. Just a second. What is happening? Okay, this is 9650 into 2 upon 96500. So this would be 0.1 into 2, which is equal to 0.2. So your number of Faradays that are calculated is 0.2. You know that number of Faradays is equal to the moles of electron. So this is equal to 0.2. So total moles of electron that are used in this electrolysis process is 0.2. You are supposed to find out the mass of Cl2. Now you know that Cl2 is formed from Cl negative when Cl negative gets oxidized. So this means that we have to use the, I'll write it in the next page. You have to write the anode reaction where oxidation takes place. Cl negative gives you half Cl2 plus electrons, right? Yes. So from this particular part, I can say that 1 mole electron gives you half mole Cl2. And if you have how many moles of electron? 0.2. So you can say that 0.2 moles of electron will give you 0.2 upon 2 moles of Cl2, which is equal to 0.1 mole Cl2. Now you have to give the mass of Cl2 liberated. For calculating the mass of Cl2, you need moles into the molar mass. Moles is 0.1, molar mass is 71 grams per mole, right? Yes, so this is 7.1 grams of Cl2. So 7.1 grams of Cl2 is liberated. So 7.1 grams of Cl2 is liberated. So this is how you will be solving these types of questions. This is the best way you will solve every question, and you need not memorize any formula as well. Okay, so try to get thorough with this particular concept. If you want to write it, you can write it, and then we'll move forward. Okay, now let's move forward, my dear students. Let's solve a few questions and then we'll end our session. So the question says that whatever we have discussed, we'll be revising. The electrolytic decomposition of dilute sulfuric acid with platinum electrode. The most important thing is here that you are given platinum electrode, that is an inert electrode. So no reactive electrode part is here. So electrolysis decomposition of dilute sulfuric acid, and you have dilute sulfuric acid. Not concentrated, it is dilute sulfuric acid. Then you have to give the cathodic reaction. Okay, so if you have dilute sulfuric acid, you have H plus and you have SO4 2 minus, you have H plus and OH minus, and since it is a platinum electrode, inert electrode, so you know that at cathode in electrolysis process, your positive ions gets reduced, and positive ion in both the cases is H plus. So H plus will get reduced. So ma'am, H plus will gain an electron and get converted into half H2. So the reduction of H plus will take place. So reduction of H plus, option A will be your correct answer. Easy? Yes. If I talk about the reaction at anode, what will you say? You just need to see the concept, that chart, and you will say OH negative will get oxidized. OH negative will get oxidized. Okay? Yes. Perfect. So option A will be your correct answer. I hope you're clear with this. You can write it and then we'll move forward. Let's move forward to the next question. Next question. Which one of the following metals cannot be obtained on electrolysis of aqueous solution of its salt? It says that which of the metal cannot be obtained from the electrolysis of aqueous solution of its salt. Okay. So now let's see, if you have aqueous solution of, let us say MgCl2. Okay, you have a aqueous solution of MgCl2. You have to make salts of every metal. Okay, so you will have Mg2 plus here and you will have H plus here. You need not discuss about this because you are only asked about the metal, and metal will be obtained on the cathode. So for cathode you need higher reduction potential. For cathode, you need higher reduction potential. Out of magnesium and hydrogen, my dear students, H plus is below in the electrochemical series, so it has a higher reduction potential. So the reaction that will take place is H plus plus electron will give you half H2. So you will not get the metal at the cathode, and so your actual answer would be magnesium only. Your actual answer would be magnesium only. In the first option you got your answer. Let me explain you the difference taking one more example. Now let's talk about Ag. If you had, let us say, Ag as your aqueous solution, then you would have let's take an example of AgNO3. It's a salt, so you'll have Ag plus and NO3 negative. and you will have H plus and OH negative. Now if you see, my dear students, at cathode the reduction potential of Ag plus is more than H plus. If you see in electrochemical series, your Ag plus is below H plus. So ma'am, it will have a higher reduction potential, so it will get reduced and you will get Ag solid at your as your metal. But this was not the case for magnesium, and this is only asked which one of the following metals cannot be obtained. Which of the following cannot be obtained? Magnesium cannot be obtained because it has a lower oxidation potential than hydrogen. Okay, all the elements which will have higher reduction potential than hydrogen will be obtained on the electrode, but the ones which have lower reduction potential will not be obtained. So magnesium will be your correct answer. It was a good question. You need to understand this. Okay, perfect. Let's move forward. Please write it and then we'll move forward. Third question. Just see the question, try the question yourself. The question says that a solution of potassium sulfate in water is electrolyzed using inert electrodes. The products at the cathode and the anode are respectively. So you have a solution of potassium sulfate. So you have K2SO4 solution. Okay. So now I can say that I'll have H plus, OH minus, and I'll have K plus and SO4 2 minus. I just need to see the reduction potentials. I know that this side I'll get cathode reduction reactions and here I'll get anode oxidation reactions. Okay. So if I see the electrochemical series, H plus has a higher reduction potential. So H plus will get reduced and the reaction would be H plus electron will give you half H2. If you talk about OH minus and SO4 2 minus, my dear students, your OH minus will get oxidized. You have to just see that chart and then the reaction would be 4 OH minus gives you 4 electrons plus 2 H2O plus O2. So what are the products at first cathode and then anode? You will have H2 and O2. H2 and O2. So H2 and O2, option A will be your correct answer, not C, my dear students, because first you have to give the product at cathode and then anode. So product at cathode is H2 and product at anode is O2. So H2 comma O2 will be your correct answer. I hope you're clear with this. Very good, my dear students. If you want to write it and then we'll move forward. Fourth question. The question says an aqueous solution of Na2SO4 in water is electrolyzed using platinum electrode, that is your inert electrode. The products at the cathode and anode are, you have Na2SO4 and that too aqueous solution. So you will have Na plus, SO4 2 minus, you will have H plus, you will have OH minus. Now let's talk about cathode and anode. You will have cathode here and you will have anode here. So now see, out of Na plus and H plus has a higher reduction potential. So H plus will get reduced. And if you talk about anode, OH minus will get oxidized. Right? Yes. So you have to give the products first at cathode and then at anode. First at cathode and then at anode. So H2 comma O2 again. So H2 comma O2, option C will be your correct answer. Perfect. Yes, very good. It was exactly the same type of question we just did. Write it and then we'll move forward. Next question, my dear students. Question says that the electrolysis of a solution resulted in the formation of H2 at cathode and O2 at anode. The solution is. Now you have to tell which of the solution is if you get H2 at anode and you get H2 at cathode and O2 at anode. Okay. So if you have AgCl, we'll take each example. If you have AgCl, you'll have let's talk about the option A, AgCl. Aqueous. You'll have Ag plus. You will have Cl minus, you will have H plus and you will have OH minus. You know that at cathode, H plus reduction potential is less and Ag plus reduction potential is more. So it will get reduced and you will get Ag as solid at anode. And what are you getting? You are getting H2 at anode. So I know that this cannot be my option correct answer. Okay, now let's talk about the B part. B part is H2SO4. If you have H2SO4 aqueous, I can say that you will have H plus, SO4 2 minus, and for water you will have H plus and OH minus. See? Yes. Now see, at cathode any H plus will go and it will give you H2 gas. And if you talk about here, OH minus will get oxidized at anode and you will get 4OH minus, giving you 4 electrons plus O2 plus 2H2. So I can say that here I'm getting H2 at cathode and I'm getting O2 at anode. So option B is my correct answer. Option B is my correct answer. Okay, yes. So this is how you will be solving these types of questions. I hope you're clear with this. Write it and then we'll move forward. I'll have water. Okay. Next question. If mercury is used as cathode in the electrolysis of aqueous NaCl solution, the ion discharge at cathode is. This is your homework. I have taught you this question. I have given you every reason to give me the correct answer to it. It is a question of reactive electrodes. Given you a hint as well. You have to try this question yourself. Okay, perfect. Next question. Can I give you this question as your homework? Please, can I give you this question as your homework? A dilute aqueous solution of copper sulfate is electrolyte using platinum electrode is the product at anode and cathode. We have done n number of questions like this. So this will be your homework question. You can do this question. Try to do this question and give me your answer. Okay, perfect. Okay, my dear students, with this we end our session today. So I hope you are very clear with each and every concept. We have discussed a very important topic today. So you need to understand each and every part. You need to try to solve the questions yourself. Okay, and I will feel very happy if you answer all the questions and let me know in the comment section. Okay, then till then you will keep studying and we'll meet in the next lecture. All the very best. Bye-bye. Take care.